And welcome to 18.2 on clouds from chapter 18. The objectives for this describe the three basic forms of clouds and explain how the shape of a cloud shows how air is moving through it. Some key ideas: there are three basic forms of clouds: cumulus, stratus, and cirrus. The shape of a cloud shows how air is moving through it, and as water vapor condenses, it releases heat. There are the key vocabulary terms as well on the side of each slide. Now, clouds are classified by their height above ground and their shape. The main types of clouds are stratus. They are the layered low clouds. So if you ever have a question or come across a description of a layered cloud, that's going to be a stratus cloud. Then there are cumulus clouds. These are fluffy clouds with flat bases, kind of look like an anvil. Then we have cirrus. Cirrus are high, feathery ice clouds. Stratus and strato describe clouds that form in layers. Stratus clouds are layered, low clouds. When you add the prefix and/or suffix nimbus or nimbo, that refers to dark rain clouds. So those would include precipitation. Now, cumulus and cumulo describes clouds that grow upward. Cumulus clouds are fluffy clouds with flat bases. Cumuliform clouds are formed by rising air, and stratiform clouds form in horizontal layers. You can see the column that forms in a cumulonimbus cloud, and that would be considered a thunderstorm. Now, cirrus and cirro describe feathery clouds. Cirrus clouds are high, feathery ice clouds. Alto cirrus is used in describing clouds located between 2,000 and 7,000 meters in the atmosphere. Now, a question: is it likely to see a sky with all three types of clouds at the same time? Try to explain why or why not. The answer is no. These clouds would not be seen together because many of them form under different atmospheric conditions. Now, Luke Howard was a pharmacist, and he spent all of his spare time, his hobby was looking at the sky and developed theories about what he saw. Now, in 1803, he wrote a paper in which he proposed a system for naming them using Latin names to classify clouds by shape. Cumulus, also meaning heap, for example. Now, there was no classification system before Howard, and for the past 200 years, some modifications, some additions, it's still being used today. Condensation level is the atmospheric level at which condensation occurs. For example, cumulus cloud formation. As that air in a growing cumulus cloud moves upward because it is buoyant and temperature is warmer than that of the surrounding air, so it rises, it's less dense. The flat cloud base shows where the water vapor began to condense. That's the condensation level. Now, below that condensation level, the air is unsaturated, so no water vapor is condensing. So how does a significant drop in temperature between 11 a.m. and 3 p.m. affect the formation of clouds, of stratus clouds? Now, air cools more quickly with altitude, and that the saturation point is reached more quickly in colder air. Just something to remember when you're trying to answer this question. The condensation level is likely to drop to a lower level in the late afternoon. After that drop in temperature, stratus clouds forming later in the afternoon will form at a lower altitude. Heat released through condensation within a cloud can cause air within the cloud to rise to great heights. The adiabatic lapse rate is the rate at which air cools as it rises. Unsaturated dry air cools at a rate of about 10 degrees Celsius for every kilometer it rises, and this is called the dry adiabatic lapse rate. Saturated moist air cools at a rate between 5 and 9 degrees Celsius per kilometer and is called the moist adiabatic lapse rate, or the moist lapse rate. So we have a dry lapse rate and a moist lapse rate, depending on the type of air. Is it dry, unsaturated, or is it moist, saturated? So let's walk through this. This is a cumulonimbus cloud forming, and we're going to look at the different lapse rates. So we'll begin. Warm air rises and water vapor condenses to begin forming clouds. Next, the next stage is although the air cools as it rises, it stays warmer and less dense than the air outside of it, so it continues to rise. So we get that column shape. When the temperature and density inside the cloud are the same as the temperature and density outside the cloud, the air spreads to the side. So then we get the anvil shape. So the dry lapse rate is about 10 degrees Celsius per kilometer, and the moist is about 5 degrees Celsius per kilometer near the condensation level of the cloud forming. So the dry is below that condensation level, the moist lapse rate is above it. Now the moist lapse rate actually increases near the top of the cloud, so it goes up to about 9 degrees Celsius per kilometer. So the bottom of the bottom layer of the troposphere, so up until about just below 0 degrees Celsius, is what we consider unstable air. Then once you get higher in altitude, in this situation, it'd be about negative 15 degrees Celsius, and colder, this is what we call stable air. Given the temperature and the dew point at ground level, meteorologists can predict the condensation level. Now condensation level again is the cloud base forms at an altitude where the temperature of the rising air equals the dew point. That's where condensation actually is taking place for that the cloud to actually form. Above the condensation level, the air in the cloud is saturated. So these three steps, you look on the left of this diagram, the temperature falls about 10 degrees Celsius for every kilometer the air rises. Then the dew point falls about 2 degrees Celsius for every kilometer the air rises. And when the temperature and the dew point are equal, water vapor condenses. So once they both reach 10 degrees Celsius, that's where the condensation level will occur. That's it for 18.2. Please check out 1 through 6 in the section review to go over these concepts, practice them, and please see your teacher if you have any questions or concerns.